Good afternoon, everybody. I hope you're all well, and I appreciate you joining me today to talk about Sparkster's Masternodes. Today, I think hopefully we're going to have a very informative session. And what I'm going to do, given that it's a Tech Tuesday, is I'm going to walk you through step by step what Sparkster's architecture looks like. And based on that, we're going to understand one, the necessity of masternodes, two, what those masternodes actually do, and three, how you can earn from running a Sparkster masternode, right? So let's begin. So let's first begin by imagining that we have a pool of masternodes. This means, a decent number of masternodes. And what we'll do is we will elect 21 masternodes to become the acting masternodes at this point in time, right? How do these get elected? Well, they guess a random number, or they generate a seed, and that seed will essentially be determined to be the lowest number. It's not like Bitcoin's proof of work, because you don't need to have specialized hardware to generate this. And I'm going to talk about why and how in a few minutes. But anyway, moving along, we've got 21 masternodes that get chosen from the pool of all masternodes. Now, ultimately, we would need to have many pools of masternodes running in parallel for us to be able to have very high TPS. And so you can imagine that you've got all of these groups of masternodes that are elected to run a certain portion of the transactions. And there are many of these groups, right? And these groups, by the way, they get rotated once an hour. Now, what we have is we also have a pool of compute nodes. And when a client, meaning a customer, let's say the customer is Panasonic or someone like that, they send a transaction to our network. They want to execute a software transaction. It arrives at a specific masternode, and that masternode randomly selects a compute node. We're going to come back to the randomness a little bit later. The compute node executes that transaction and stores the outputs or stores the data of that transaction into the storage cell. And remember, there are many storage cells, so all of this stuff is happening in parallel, right? And then the masternodes receive notification of that transaction. And what the masternodes essentially do is they sorry, someone's calling this room. What the masternodes do is they arrive at, they essentially share that information amongst themselves, right? Then they choose a verification node each, and there's 21 of them, so 21 verification nodes are selected. And those verification nodes then go and get that transaction from the storage node and essentially arrive at consensus on that transaction and share their results back with those masternodes, right? So now let's break down, what are these nodes actually doing? What are these masternodes actually doing, right? So the first thing they're doing, the first thing they're doing is that they're nominating compute nodes, and that they're also nominating verification nodes. Now, what's important about this nomination process is that the nomination process has to be random, right? Because if it's not random and they start choosing their friends or whatever it might be, there's a chance that this might be rigged, or there's collusion going on. So what we use is we use a technology from Intel called Intel SGX. And what Intel SGX does is it allows us to run the random number generator inside of a protected part of the processor, right? With protected memory. And because it's protected, we can not only validate the output, we can validate the input too. Like what went in, what was actually done, input, process, output, can all be validated in the form of a signature or something like a signature, right? And this is something that's provided by Intel. And so this is one of the ways in which we can validate the authenticity of our network, and also enables us to have, a relatively small number of masternodes, 21 per pool, if you will. Now, those masternodes, like I said before, they win the right. Well, how do we know that they've legitimately won the right? Well, it's using the same methodology, using Intel SGX. And if one of those, I'm going to kind of come to this later, but if they start cheating, then we know that they've cheated, right? They also update the blockchain and gossip with one another about kind of everything that they've received and what's going on. That's how they have their own independent awareness of what's going on, right? So the real question, and the real question that you guys want us to address, is how do you make money from a masternode, right? Well, the first thing is that a masternode is coordinating transactions, right? And if a masternode, say, is coordinating 10,000 transactions a second, you're earning from those 10,000 transactions a second. So while it might be small on an individual transaction, you're coordinating thousands of transactions a second, right? And you're earning from thousands, maybe 10,000 transactions a second. This also points to why we need multiple groups of masternodes, right? So how do we get to millions of transactions per second? Well, we have multiple groups of masternodes that are acting upon a subset of transactions, right? And then secondly, going back to SGX, if you find, because what those masternodes are doing is all verifiable, you can go back and see, did they nominate a friend to be a verification node? Did they consistently nominate somebody to be a compute node? Did they cheat in their election process? And if you find any of these people cheating, you get to steal their stake. And as we've been talking about in the group, the size of the stake that a masternode puts up is sizable, right? I mean, it's large. Now, compare that to, for example, the stake that a compute node puts up or a storage node puts up. It's considerably smaller. The storage node or the compute node has the ability to choose their own stake size, right? So it may only be, for example, one Spark token. And we talked in previous tech talks, I believe in 2 weeks ago, the tech talk, about how the probability of being assigned a transaction for a compute node or a storage node is based on the number of tokens they stake, right? Well, that's not the case here with masternodes. Masternodes have to meet a threshold, and then they randomly get the right to be able to participate as a masternode in one of those masternode groups, right? And they're in that particular group for some short period of time. Let's say we're thinking about an hour. So there are multiple groups, you're switching between groups. And if at any one point in time you find yourself not part of a group, well, then you can use that time to validate the transactions that other masternodes are producing. So this is how we can all keep ourselves accountable and ensure the network is safe, right? Now, before we move on, I do want to go back and point out, how is this different to, for example, EOS? Because EOS also has, 21 active masternodes. And the one thing that's different is that the verifiers of transactions in EOS are the masternodes themselves. And so this inhibits the performance. Why? Because if you've got 21 verifying nodes that are verifying one transaction, you can have a different set of 21 verifying nodes verifying another transaction. And you can have different groups of 21 verifying nodes verifying different transactions, all in parallel. And then again, you've got all of that occurring in parallel with different groups of masternodes. So this is how we don't have some of those performance limitations, and we will be able to achieve I think it's obvious how we will be able to achieve extremely high levels of TPS across the entire network, right? So continuing, how do masternodes cheat? They collude with other masternodes, or they collude with compute or verification nodes who are their friends. And what's the solution to this? We generate true random numbers inside of Intel SGX in a way that's verifiable. And if you want to learn about random number generation and some of the challenges and complexities of that, I recommend listening to reading this week's discussion that came from the tech team, because it's highly focused on this idea of generating true random numbers and some of the challenges and pitfalls, because that's currently what the team is working on. So the question you might all be asking is, how easy is it to run a masternode? Well, our goal is to make this extremely simple. You install some software on your computer, and the software is so automated, it takes care of everything else. It does its job of, generating the seed to participate in the election process. It automatically gets elected and put into a group. Transactions are sent to it. It coordinates those transactions and so forth. So our goal here is to make this so simple that for you guys, it's as simple as just installing software on your computer, right? So that we can get as many people as possible to participate in the masternode process. So as you know, the goal here is to keep these conversations short, but hopefully in these 10 or 12 minutes, you guys have learned about the sophisticated architecture behind Sparkster. And you've also learned about how Sparkster is going to achieve extremely high TPS, not just in the storage tier, not just here in the blockchain component, but across the entire network, and how we address some of the challenges that other networks have or potentially have. Thank you everyone for your time. It's been a pleasure to be here with you, and I look forward to catching up with you in the next AMA, which will be on Friday. Take care, everybody, and thank you.